Hello everybody, today we're going to solve some exponential equations. Now we have a few problems that we need to solve. Now here I wrote the steps on how to solve an exponential equation. You can either write both sides of the equation with the same base, and if you do that you can set the powers equal to each other. And if you cannot do that, then you go to the second way of solving exponential equation, and that is you take the log or ln on both sides of the equation. So let's go ahead and do this. Here we have 4 to the x is equal to 64. Now I do not have the same base, but you need to ask yourself, can you write it with the same base? If you realize here you have 64 is just 4 cubed, right? So that means I have both sides of the equation have the same base 4. So you can set the powers equal to each other. So that means that x is equal to 3. And we just solve this equation. Okay. Now that is one of the simplest one of the simplest exponential equation you can solve. Now let's take a look at number 2. And number 2 here, we do have the same base. All you have to do, you set the powers equal to each other. So it's negative 3x minus 2 equal to negative x. Now you solve for x. You have the option to either take the x on the left side or take that to the right side. I'm going to go ahead and take this to the right side. So this cancels. And then here you have negative 2 equal to 3x minus x. And that will be 2x. You divide by 2 to isolate the variable, and then you get x is equal, this cancels, negative 2 divided by 2 is negative 1, and that is your solution. Okay? Now, number 3 here, we have 625 times 5 to the 3x plus 3 equal to 125. Now, you have to make sure here you want to isolate the exponent here, 5 to the 3x plus 3. So 625 is multiplied by that, so we need to divide both sides by 625. So this cancels. Now you're left with 5 to the 3x plus 3 equals. Now you notice here you can simplify, right? So you divide this, they're both divisible by 125. You divide this by 125, you get 1. And if you divide 625 by 125, you get 5. If you take a look here, you notice that you have a 5 here and 5 here, but you realize this 5 is in the denominator. How do you take it to the numerator? Now if you recall, I want to remind you of a rule, the negative rule of exponent. This is equal to 1 over a to the n, and 1 over a to, you can go the other way around, 1 over a to the n is a to the negative an. So what we have here is 1 over 5 to the 1, that would be 5 to the negative 1, right? So now we have 5 to the 3x plus 3 equals to 5 to the negative 1. And we just wrote both sides of the equation with the same base, 5. And now we set the powers equal to each other. So now what we have, 3x plus 3 equal to negative 1. And you just solve for x. So we subtract 3 on both sides. And we get 3x, this cancels. Negative 1 minus 3 is negative 4. You divide by 3 on both sides, and we get the solution. X is equal to negative 4 over 3. So that is your solution for this problem. This 3 and this 3 cancels. Okay. So far in all 3 problems, what we did is we wrote both sides of or they either given us the same base or we changed it so that we have the same base, like in number 1 and number 3. Now let's go ahead and do a couple of other problems. Number 4. You have 2e to the 6x equal to 13. Now here we have the base e. So don't try to go by the first method. You have to take the log on both sides. Now, before you do that, you need to get rid of the 2. So remember, the exponent has to be separate. So we have to divide by 2 on both sides of the equation. And this cancels out, and we'd be left with e to the 6x equal to 13 over 2. Okay? Now, we have to take the log. It is advised to take either ln or the log. LOG, the common logarithm, because that's what we have in your calculator. If you go in, you see that you have log and ln. So that's what we do. However, since we have e, you should always, whenever you have the base e, you should take ln, right? So remember, ln is a natural logarithm. Now we take the ln on both sides. Now we use the third property of remember, the third property of logarithm, you bring down the power. This is 6x ln e equal to ln 13 over 2. Now, if you recall, ln e is equal to 1. Ln e is equal to 1. Remember, the base is e to the 1 is e. And then if you plug it in your calculator, that's what you should get as well. So ln e is 1. So that would give us 6x equal to ln 13 over 2. Now you want to solve for x, so you want to get rid of the 6. You can divide by 6 on both sides. I would recommend multiplying by 1 over 6. So now you divide by 6 here. You get x is equal 1 over 6 ln 13 over 2. So this is your exact solution. A lot of times you'll be asked to give the exact solution. Sometimes you'll ask you to approximate it. So this is where you bring your calculator and you solve. Okay, 1 over 6 times ln 13 over 2. Now let's do number 5. In number 5 here, you have a base 2 and base 5. You cannot write them with the same base. So this does not apply here. You have to use the second method here. If you cannot write both sides of the equation with the same base, we have to take the log or ln. It doesn't really matter which one you take. I usually take the log if you have numbers and take ln if you have e. It doesn't really matter. Log or ln would work. It doesn't matter. So I'm going to take the log. I've noticed that the book uses ln. It doesn't really matter which one you use. It would work for both. So you have log 2 to the x plus 1 equal to the log 5 to the 2x minus 1. Okay, now this will bring down the power here. That's 2x plus 1 log 2. Please do not leave it like this. Make sure you have parentheses. The whole power is multiplied by log 2. The same thing applies on the right side of the equation. You bring down 2x minus 1, you get log 5. Now remember, you are solving for the variable x. You want to get the variable out of the parentheses. So that's what we're going to be doing here. Oops, what did I do? I included the 2. I'm sorry about that, so no problem. X plus 1 log 2, and here 2x minus 1. This is correct. 2x minus 1 log 5. So this is, so you just bring down the variable, not the variable, it's more than the variable here, the variable plus 1. You bring down the power using the power rule of logarithm. So x plus 1 times log 2. Now we are solving for x, so let's go ahead and distribute. We want to get the x out of the parentheses on both sides of the equation. So we get x log 2 plus 1 times log 2 or log 2 equal, now we do the same thing here, we distribute 2x. So 2x log 5 minus log 5. Now again, you want the variable on one side, so I'm going to take this to the other side, so we subtract 2x log 5. Why do we do that? Well, we want the variable on one side so we can factor it out. Okay, now notice here, can you factor x? Okay, so this side cancels out, so you are left with, let me write it again so that you get that. So x log 2 minus 2x log 5. Okay, I can also take this to the other side, so let me go ahead and subtract it with another color. So minus log 2 minus log 2. So I get the x on the left side of the equation, I take the logs on the right side of the equation. Negative log 5 minus log 2. By the way, this is none other than a number. What is log 5? You can go ahead and use your calculator. Here, log 5 is just a number. So here, log 5, and you get 0.6989. So this is just a number. We're isolating x on the left side. Let's factor x. We get log 2 minus 2 log 5 equal to negative log 5 minus log 2. Now we divide both sides by log 2 minus 2 log 5. So this way, we isolate the variable on the left side of the equation. Log 2 minus 2 log 5. So this cancels, and here's your x. Now, you can, if you want to simplify it, you can, if you want, factor out the negative and simplify it, but we're going to leave it like this. This is the exact answer. You can simplify it a lot more, but for now, I'm good if you understand it up to here. And I hope you found this video helpful. See you next video. Have a good day, everyone. Bye-bye.